Standard IETF calendar protocols, the foundation for tools like Outlook and Google Calendar, were designed strictly for one-to-one communication. They assume a simple peer-to-peer exchange of invitations between individuals. When developers try to build modern programmatic integrations on top of these legacy rules, data pipelines hit a solid, impenetrable barrier. Traditional workarounds are notoriously high friction, forcing developers to build clunky, custom OAuth flows or rely on users manually downloading and opening individual ICS files. The Calendar Invite Server, or CIS, moves past these bottlenecks by treating standard calendar clients as decoupled databases. This architecture bypasses the need for complex OAuth authorizations by weaponizing AWS Simple Email Service as a raw data ingestion point. The basic serverless pipeline starts here. An SES ingestion node receives the data, triggers a Lambda function for processing, and passes the result to an API gateway. This process extracts standard IETF calendar data and assigns it a sticky, trackable, unique identifier, or UID. The result of this extraction is a headless, highly programmable REST API, derived from what was once a closed peer-to-peer system. Developers gain the ability to execute one-click calendar invite distribution across any digital surface. This pipeline transforms the native calendar client into a programmable serverless control plane. The workflow begins with the organizer, whether a human or an AI agent, performing standard CRUD commands natively within their Google or Outlook client. Ingestion is triggered by a single action, adding a specific AWS SES email address to the event's guest list. Inviting this dedicated mailbox acts as the primary programmable trigger for the entire AWS backend. As the calendar client sends the invite, the raw kmode hits the SES inbox, serving as the source of truth for the entire pipeline. AWS Lambda functions immediately initiate an ETL disassembly process, stripping the raw invite down to its core metadata. The system then generates a sticky UID that cryptographically ties the event to the organizer's native client ID. This normalized data is securely stored, ensuring the original calendar client remains the definitive source of truth. Unlike traditional database management, developers no longer need to build and maintain custom user interfaces for event creation. Ingestion is fully decoupled from distribution, rendering the calendar data entirely headless and programmable. With the database populated, the normalized event data is now accessible via REST APIs. These APIs can be embedded directly into static web environments to generate dynamic, live schedules. This generated sports schedule demonstrates the practical result. Users simply enter an email address and click the green Send Invite buttons to execute the distribution. The second distribution pathway handles batch processing and CRM integrations through embedded email call-to-action buttons. In this MailChimp template, the Calendar Invite Send API is linked to a single RSVP button, allowing a marketing funnel to leverage the server without forcing a user to leave their inbox. The third pathway brings this headless data into conversational AI interfaces. Using a Google Firebase bridge, an LLM like Claude can dynamically query the server's display APIs for specific event data. When Claude queries the game schedule, it renders a verified calendar invite directly within the chat window. Because the Action API is embedded in the prompt itself, the user completes a one-click execution without any secondary steps. A single SES ingestion event now powers limitless, decoupled distribution services without requiring custom OAuth authorizations. The system also manages the return leg of the data journey, monitoring when a user clicks yes, no, or maybe in their calendar. Standard IETF calendar receipts travel backward from the user's inbox, through the SES pipeline and the API gateway, before depositing into the central database. Capturing these RSVP states allows the server to populate real-time telemetry and reporting dashboards. This closed loop addresses a critical synchronization problem. What happens when an organizer changes event parameters after the invites have gone out? Consider an update scenario where an organizer adds a limited merchandise offer to the event description at the last minute. The organizer makes this change natively in their calendar client. Hitting save sends the data back through the SES pipeline a second time. The backend scans the payload and matches the existing sticky UID already in the database. An AWS Lambda function, the update processor, categorizes the payload as a state change request for an existing event. The system references the RSVP telemetry and dispatches the updated IETF payload exclusively to users who previously responded yes or maybe. This continuous loop automates post-event synchronization and targeted marketing, removing the need for manual list management. This end-to-end AWS architecture provides a complete overview of the system's logic. We can trace the full lifecycle: SES ingress, Lambda ETL, API gateway distribution, and the continuous RSVP feedback loop. The system originates from a universally accessible, low-friction interface. It leads to infinite endpoints, all powered by the headless architecture. This bridges standard human-in-the-loop workflows with advanced headless automation. Utilizing AWS SES as an IETF data ingestion layer abstracts away decades of legacy protocol complexities. This modern serverless approach scales effortlessly across the network, simultaneously supporting many thousands of concurrent human users and autonomous AI agents. By decoupling the protocol from the interface, developers transform the humble calendar client into a programmable serverless control plane.